Okay. Hello, my name is Samantha Bayard, and Environment and Climate Change Canada spokesperson, and I'll be moderating today's media availability with regards to Canada's rapid extreme weather event attribution system and results gathered during summer 2024. I'd like to begin by acknowledging I'm coming to you today from unceded territory of the Anishinaabe Algonquin Nation. To begin, a few points before we begin. The presentation will first occur in English and be followed by a presentation in French. We'll then move to a question period. Nathan Gillett, climate research scientist, and Jennifer Smith, national warning preparedness meteorologist, will be presenting in English and in French on behalf of Environment and Climate Change Canada. Their presentations and the question and answer period that follow can be recorded and are for attribution. They can be quoted. To be called upon, we ask that you make sure your name and your media outlet are clearly identified in your Zoom name. In the interest of time, please keep it to one question and one follow-up. Please note that this will be the primary opportunity for media to speak with Environment and Climate Change Canada climate researchers on this topic. Bonjour, je m'appelle Samantha Bayard, porte-parole à Environnement et Changement Climatique Canada. Et aujourd'hui, je suis la modératrice de la conférence de presse concernant le système canadien d'attribution rapide des événements météorologiques extrêmes et les résultats recueillis au cours de l'été 2024. Je tiens tout d'abord à souligner que je viens aujourd'hui de le territoire non cédé de la nation algonquine Anishinaabe. Avant de commencer, j'aimerais soulever quelques points. La présentation se fera d'abord en anglais et suivie par une présentation en français. Nous passerons ensuite à la période de questions. Nathan Gillett, chercheur de la climatologie, et Jennifer Smith, météorologue nationale de sensibilisation aux alertes, feront une présentation en anglais et en français au nom de Environnement et Changement Climatique Canada. Leur présentation et la période de questions et réponses qui suivent peuvent être enregistrées et sont destinées à être attribuées. Elles peuvent être citées. Pour être sollicité, nous vous demandons de veiller à ce que votre nom et votre nom de média et nom de Zoom soient clairement identifiés. Pour gagner du temps, veuillez vous tenir à une seule question et un suivi. Veuillez noter qu'il s'agit d'une première occasion pour les médias de s'entretenir avec les chercheurs en climatologie du ministère de l'Environnement et Changement Climatique Canada. Alors, merci. On continue avec Jennifer.
Okay. Good day, everyone. My name is Jennifer Smith, and I'm the National Warning Preparedness Meteorologist at Environment and Climate Change Canada. Today, I'll be providing a quick overview of summer 2024 in Canada, focusing on heat events, why they happen, and factors that influence their impacts. This exploration will help us refresh our memories on the season and prepare for my colleagues to discuss extreme weather event attribution. Next slide, please. In Canada, the seasonal heat was felt in different ways throughout the summer and across the country. There were early bursts of warmth and persistent humidity with prolonged heat events that tested our resilience. Northern Canada recorded significant heat, and interestingly, many regions encountered the unusual challenge of simultaneous heat warnings and air quality advisories. But first, let's delve into the meteorology behind these heat events. Next slide, please. In general, a heat wave or heat event is an extended period of unusually hot weather. Most are caused by slow-moving or stationary high-pressure systems. Essentially, they hold or trap warm air in one spot for a prolonged period, similar to putting a lid on a pot, trapping heat inside. In the atmosphere, this trapped air is forced to sink, and as it does, it compresses and heats up, resulting in elevated surface temperatures. While these systems are common in Canadian summers, their location, duration, intensity, frequency, and the influence of high humidity or poor air quality all contribute to the impacts experienced. Next slide, please. As we dive into the temperature anomalies by month, it's crucial to understand what these maps represent. Rather than indicating how hot it was, they show us the departure from what is considered normal climatology. Throughout the summer, we saw above normal temperatures shift across different regions of Canada. So generally speaking, we'll review each month. In June, June brought an early blast of summer heat to Eastern Canada, especially for coastal locations such as the Maritimes and lakeshore regions of Ontario. Quite a contrast from the cool start to the summer in Western Canada, as can be seen by the blue on the map. This widespread heat event was one of the earliest in the region's history, and it posed significant challenges as many schools were still in session and lacked air conditioning. In July, impactful heat was centered in the West, where two long duration heat events occurred. This was driven by a high pressure system centered over Northern California, which expanded north and east to affect parts of Western Canada. While these types of heat events are common in the southern regions of British Columbia and the prairies like Brooks, Medicine Hat, and Cypress Hills, this year significant heat reached northern Alberta and southern areas of the Yukon and Northwest Territories, as well as Fort Nelson, BC. Temperatures set several daily records across this vast region, though most remained just below all-time highs. What stood out was the duration of the heat event, driven by warm nighttime lows that prevented any substantial relief, thus extending heat warnings. Notably, Kelowna and Cranbrook in the British Columbia interior experienced an uninterrupted stretch of above normal temperatures with no break between the two heat events, resulting in heat warnings for 18 consecutive days, a staggering number compared to previous years. Mid-month and toward the end of the month, periods of humid heat once again affected parts of Ontario, Quebec, and the Atlantic provinces. When looking at August, it is really the extraordinary heat in the north, particularly the Inuvik region of the Northwest Territories and the western Kitikmeot and Kivalliq regions of Nunavut that draws attention. My colleagues will go into greater detail on this, but temperatures essentially soared above 30 degrees and several all-time records were broken in these regions. This summer's significant heat also affected regions that typically don't meet heat warning criteria, such as many of the islands. Adding to the challenge for the communities at high latitudes is the long summer days, meaning there are fewer hours for cooling off during the night. Lastly, in September, the well above normal temperatures were noted around James Bay, Hudson Bay, and extending north into the Kikitalik region of Nunavut, although many areas across the country exceeded seasonal averages at times throughout the month. While excessive temperatures in June, July, and August led to significant health implications and widespread heat warnings, September usually marks a transition to cooler weather, with average temperatures typically ranging from 10 to 20 degrees Celsius across southern Canada and even cooler further north. Therefore, elevated temperatures in this context no longer trigger health impacts or warnings. Instead, the excessive heat alters people's way of life, influencing daily activities and cultural practices. This is something to keep in mind when observing all of the red on the September map. Next slide, please. To tie in with the previous slide, these are the all-time records that were broken. Notably, most of the max temperature records are in the east and in the north in June and August, respectively. What is also quite interesting is the number of all-time warm overnight low records that were broken. This is due to high humidity in the atmosphere, preventing temperatures from dropping off overnight. Next slide, please. So why is reflecting and analyzing summer heat important? Heat events are one of the most dangerous weather-related hazards from a health standpoint, particularly affecting those most vulnerable among us. Examining past heat events helps inform attribution studies, which in turn aids extreme weather mitigation and adaptation planning. So with all of that said, I will now pass the microphone to my colleague Nathan to speak to his team's event attribution analysis. Thank you.
Thank you, Jennifer. Next slide, please. So I'll start with this slide, which just summarizes the temperatures across Canada as a whole for 2024. You can see that it was warmer than average almost everywhere over the months of June, July, and August on average. And nationally, summer 2024 was the fourth warmest on record for Canada. In Atlantic Canada and Quebec, it was the warmest summer on record. And this is part of a clear long-term warming trend. Over the past 77 years, summer temperatures have warmed by 1.7 degrees Celsius nationally on average. And the principal cause of this warming is human-induced climate change. Next slide, please. So when an extreme event occurs, how do we understand the causes of that event, or how do we attribute that event? Well, this graphic on the right shows the distribution of an extreme event. It could be the hottest temperature observed each year in red. So that would be in the current climate, in the climate with human influence. And that distribution we obtained from climate model simulations. And we compare that with the distribution of the maximum temperatures without human influence in a pre-industrial climate. And then when an extreme event occurs, as indicated by the black line, we can calculate the probability of an event at least that strong in the current climate, indicated by the pink shaded area, and we can compare that with the probability in a climate without human influence, indicated by the blue shaded area. And that essentially is an event attribution analysis. Next slide, please. So typically, these kind of event attribution studies take months or even years to carry out. But we've developed an automated system that can analyze the extent of human influence on a heat wave within about a week of it occurring in Canada. And these kind of results from rapid event attribution analyses can help inform adaptation planning, can help inform the response after an extreme event, a quantitative understanding of how climate change is affecting that kind of extreme event. Next slide, please. Okay, so this slide summarizes some of the results of our system for summer 2024. We analyzed, for the attribution analysis, we analyzed results over 17 regions across Canada, as shown on the map. And the dates shown on the map are the hottest heat wave day recorded in each region. For all the events that we analyzed, we found that they were made more likely, significantly more likely by human-induced climate change. And the strongest effect of climate change was seen for events occurring in the north, including the event that Jennifer mentioned in early August in the Inuvik region, as well as in the Kitikmeot and Kivalliq regions of Nunavut. Next slide, please. So altogether, we analyzed 37 heat waves through the summer. Of those, the longest event was in southern Qikiqtaaluk in September and October, and that event lasted 25 days. That event was above the average, well above the average conditions expected for the time of year. The hottest event in absolute terms was in Alberta in July, and the hottest event in terms of the anomaly from the typical conditions was in Inuvik in August, and I'll give some more results for that event later in the presentation. The numbers on the right summarize the results of our system for the summer. As I mentioned, all the heat waves that we analyzed were made more likely by human-induced climate change, and the largest number fell into the category of much more likely, which corresponds to at least twice as likely because of human-induced climate change. Next slide, please. Okay, so this slide shows the daily maximum temperatures in the Inuvik region in red. You can see that there was a very strong heat wave in early August in this region, indicated by the shaded area. Jennifer already showed, so this is an average for the region. Jennifer already showed that in the town of Inuvik, maximum temperatures close to 35 degrees Celsius were observed. And this Inuvik is not far from the Arctic Ocean. So this is really exceptional in that region. Next slide, please. So this slide shows the results of our attribution analysis for that event. On the left, you can see the distribution of maximum temperature anomalies in the current climate for the Inuvik region in red, and you can compare that with the blue distribution of those temperatures in the pre-industrial climate. And you can see there's a clear shift towards higher temperatures due to human-induced climate change. The observed value is indicated by the black arrow there. You can see that it was a very rare event, even in the current climate, but it would have been much more rare in a climate without human influence. And the results of our analysis indicate that this event was at least 10 times more likely because of human-induced climate change. Next slide, please. Where do we plan to go next with the rapid extreme weather event attribution system? Well, we're developing capabilities for attribution of cold extremes, and those will be in place by this winter. We're also developing capabilities for attribution of precipitation extremes, rainfall extremes, to be in place by 2025. Next slide, please. So I'll conclude there. I'll leave you with some links to obtain information on weather in Canada. Thank you.
Bonjour à tous, je m'appelle Jennifer Smith et je suis météorologue nationale de sensibilisation aux alertes à Environnement et Changement climatique Canada. Aujourd'hui, je vais vous donner un bref aperçu de l'été 2024 au Canada en mettant l'accent sur les événements de chaleur, les raisons pour lesquelles ils se sont produits et les facteurs qui influencent sur les effets. Cette exploration nous aidera à rafraîchir nos souvenirs de la saison ainsi que nous préparer pour la discussion de mes collègues concernant l'attribution des événements météorologiques extrêmes. Prochaine diapositive. Au Canada, la chaleur saisonnière a été ressentie de différentes façons tout au long de l'été et à travers le pays. Il y a eu des événements de chaleur au début de la saison et une humidité persistante avec des épisodes prolongés de chaleur qui ont mis à l'épreuve notre résilience. Le nord du Canada a connu une chaleur importante. Fait intéressant, de nombreuses régions ont eu le défi inhabituel d'avoir des avertissements simultanés de chaleur et des avis sur la qualité de l'air. Mais d'abord, plongeons-nous dans la météorologie qui explique ces événements de chaleur. Prochaine diapositive. En général, une vague de chaleur ou un événement de chaleur est une période prolongée de temps exceptionnellement chaud. La plupart sont causés par des systèmes de haute pression lente ou stationnaires. Principalement, ils retirent ou impressionnent l'air chaud à un endroit pendant une période prolongée, semblable à un couvercle qui est mis sur une peau, piégeant la chaleur à l'intérieur. Dans l'atmosphère, cet air impressionné est forcé de s'enforcer à mesure que l'air se comprime et se réchauffe et les températures de surface deviennent encore plus élevées. Bien que ces systèmes météorologiques soient courants au Canada pendant l'été, leur emplacement, leur durée, leur intensité, leur fréquence et l'influence d'une humidité élevée ou d'une mauvaise qualité de l'air contribuent à l'impact que la chaleur estivale peut avoir. Prochaine diapositive. Alors que nous examinons les anomalies de température par mois, il est crucial de comprendre ce qui représente ces cartes. Plutôt que d'indiquer la chaleur, elles nous montrent les cartes par rapport à ce qui est considéré comme une climatologie normale. Tout au long de l'été, nous avons observé des changements de température supérieurs à la normale dans différentes régions du Canada. En général, juin a été l'occasion d'une première vague de chaleur estivale dans l'Est du Canada, surtout pour les régions côtières comme les Maritimes ou les régions riveraines de l'Ontario. Tout un contraste entre le début frais de l'été dans l'Ouest du Canada, comme on peut voir sur la carte en bleu. Cet épisode de chaleur généralisée, l'un des plus précoce dans l'histoire de la région, a créé des défis importants car de nombreuses écoles étaient encore en session et n'avaient pas l'air conditionné. En juillet La chaleur importante s'est concentrée à l'ouest, où deux épisodes de chaleur de longue durée se sont produits. Cette situation était causée par un système de haute pression centré sur le nord de Californie qui s'est entendu vers le nord et l'est pour toucher des parties de l'ouest du Canada. Bien que ces types d'événements de chaleur soient courantes dans les régions du sud de la Colombie-Britannique et des prairies comme Brooks, Medicine Hat et Cypress Hills, cette année, une chaleur importante a atteint le nord de Alberta et le sud du Yukon et des territoires du nord-ouest, ainsi que Fort Nelson, Colombie-Britannique. Les températures ont établi plusieurs records quotidiens dans cette vaste région, bien que la plupart soient restés juste en dessous des records historiques. Ce qui a été particulièrement frappant, c'est la durée de l'événement de chaleur, alimentée par les températures nocturnes minimales chaudes qui ont empêché tout soulagement important, prolongeant ainsi les avertissements de chaleur. Kelowna et Cranbrook, dans l'intérieur de la Colombie-Britannique, ont connu une période continue de température supérieure à la normale sans interruption entre les deux épisodes de chaleur, ce qui a donné lieu à des avertissements de chaleur pendant 18 jours consécutifs, un nombre impressionnant par rapport aux années précédentes. Des périodes de chaleur humide en milieu de mois et vers la fin du mois ont encore touché certaines régions de l'Ontario, du Québec et des provinces de l'Atlantique. En regardant le mois d'août, c'est vraiment la chaleur extraordinaire dans le nord, particulièrement la région d'Inuvik, dans les territoires du nord-ouest et dans l'ouest des régions de Kitikmeot et de Kivalliq au Nunavut qui attirent l'attention. Les températures ont grimpé au-dessus de 30 degrés Celsius, ce qui a permis de battre plusieurs records historiques. Cet été, des chaleurs importantes ont également touché des régions qui ne répondent généralement pas aux critères d'avertissement de chaleur, comme un bon nombre des îles. Les longues journées d'été ajoutent un défi pour les collectivités situées à des latitudes élevées, car il y a moins d'heures de refroidissement la nuit. Enfin, en septembre, des températures bien supérieures à la normale ont été observées autour de la baie James, de la baie d'Hudson et dans la région Qikiqtalik de Nunavut, bien que de nombreuses régions du pays ont dépassé des moyennes saisonnières par moment tout au long du mois. Bien que les températures excessives de juin, juillet et août aient entraîné des répercussions importantes sur la santé et des avertissements de chaleur généralisés, septembre marque habituellement une transition vers un temps plus frais, avec des températures moyennes qui varient généralement entre 10 et 20 degrés Celsius dans le sud du Canada et plus froid encore au nord. Par conséquent, les températures élevées dans ce contexte ne déclenchent plus d'effets sur la santé ou d'avertissement. Au contraire, la chaleur excessive altère le mode de vie des gens, influençant les activités quotidiennes, je m'excuse, et les pratiques culturelles. C'est quelque chose à garder à l'esprit lorsque vous observez tout le rouge sur la carte du mois de septembre. Prochaine diapositive, s'il vous plaît. Pour faire le lien avec la diapositive précédente, il s'agit des records historiques qui ont été battus. La plupart des relevés de température maximale sont enregistrés dans l'Est et le Nord, en juin et en août respectivement. Ce qui est également intéressant, c'est le nombre de records de température nocturne minimale de tous les temps qui ont été battus. Cela est dû à l'humidité plus élevée de l'atmosphère qui empêche les températures de baisser pendant la nuit. Diapositive suivante. Cela dit, pourquoi est-il important de refléter et d'analyser la chaleur estivale? Les épisodes de chaleur sont l'un des dangers liés aux conditions météorologiques les plus dangereux du point de vue de santé et touchent particulièrement les personnes les plus vulnérables parmi nous. L'examen des épisodes de chaleur extrême passés aide à éclairer les études d'attribution qui, à leur tour, contribuent à l'atténuation des phénomènes météorologiques extrêmes et à la planification de l'adaptation. Après cette brève introduction, je vais maintenant céder la parole à mon collègue Nathan pour qu'il nous parle de l'analyse d'attribution des événements de son équipe. Merci.
Euh, Merci beaucoup, Jennifer. Alors, je vais commencer avec cette carte qui montre les températures estivales moyennes au Canada. On peut voir qu'en 2024, les températures étaient plus chaudes que normal presque partout au Canada pendant l'été. Alors, et à l'échelle nationale, l'été de 2024 a été le quatrième plus chaud jamais enregistré. Le Canada Atlantique et le Québec ont connu leur été le plus chaud jamais enregistré. Et on a vu une tendance de réchauffement au long terme. Au cours des 77 dernières années, les températures estivales se sont réchauffées de 1,7 degrés Celsius en moyenne à l'échelle nationale. Et ce réchauffement est causé principalement par les changements climatiques d'origine humaine. Prochain diapo, s'il vous plaît. Alors, si on observe une vague de chaleur ou un extrême, comment est-ce qu'on peut attribuer cet événement? Alors, le graphique à droite montre la distribution d'un événement, par exemple la température maximale annuelle en rouge. Et alors, le rouge indique le climat actuel avec la contribution humaine. Et on peut comparer cette distribution avec la distribution bleue qui indique le climat sans la contribution humaine. Et on utilise les modèles climatiques. Alors, ces distributions viennent des modèles climatiques. Et si on observe un événement extrême indiqué par la ligne noire, on peut comparer la probabilité d'un événement aussi fort dans le climat actuel indiqué par l'air rouge. Et on peut comparer ça avec la probabilité dans le climat sans contribution humaine indiqué par l'air bleu. Et cette comparaison, ça c'est une attribution, une analyse d'attribution. Prochain diapo, s'il vous plaît. Alors, normalement, ce genre d'études d'attribution dure des mois ou même des années, mais nous avons développé un système automatique qui peut analyser les vagues de chaleur, qui peut attribuer des vagues de chaleur en une semaine. Et le résultat de ce système peut éclairer la planification de l'adaptation et la réponse après des événements extrêmes. Prochain diapo, s'il vous plaît. Alors, cette carte montre les résultats de notre système pour cet été. Alors, on analyse les températures maximales dans 17 régions du Canada. Les vagues de chaleur les plus chaudes de l'été 2024 sont indiquées sur cette carte. On peut voir que tous les vagues de chaleur que nous avons analysées étaient plus probables à cause des changements climatiques. On peut voir une influence plus forte sur les vagues de chaleur dans le nord, en particulier, par exemple, à Inuvik, sur l'événement au début d'août. Prochain diapo, s'il vous plaît. Alors, nous avons analysé 37 vagues de chaleur au Canada cet été. Vous pouvez voir ces résultats sur notre site web. L'épisode le plus long, c'était dans le sud de la région Kikik-Taluk en septembre et octobre, et ça a duré 25 jours. L'épisode le plus chaud, c'était en Alberta en juillet, et l'épisode le plus chaud en termes des anomalies, c'était dans la région d'Inuvik en août. Et je vais vous montrer plus de résultats concernant cet événement. À droite, on peut voir des statistiques qui summarisent les résultats de notre système pour cet été. Comme j'ai dit, tous les événements que nous avons analysés étaient plus probables à cause des changements climatiques. La plupart des événements étaient dans la catégorie beaucoup plus probable, qui indique que les événements étaient au moins 2 fois plus probables à cause des changements climatiques. Prochain diapo, s'il vous plaît. Alors, la plus forte vague de chaleur était dans la région d'Inuvik au début d'août. Cette graphique indique la température maximale quotidienne dans la région d'Inuvik et on peut voir qu'on a vu une vague de chaleur très forte au début d'août dans cette région. Alors, cette graphique, c'est pour la région d'Inuvik. Jennifer vous a montré que dans la ville d'Inuvik, on a observé une température de presque 35 degrés pendant cet événement. Alors, Inuvik, c'est pas loin de l'océan Arctique. C'est vraiment exceptionnel pour cette région. Prochain diapo, s'il vous plaît. Alors, cette graphique montre les résultats de notre analyse pour cette région. La distribution rouge indique le climat actuel et la distribution bleue indique le climat pré-industriel, les anomalies de la température maximale. On peut voir que le climat actuel est plus chaud à cause des changements climatiques. La flèche noire indique la valeur observée le 9 août à Inuvik, dans la région d'Inuvik. Et on peut voir que c'était un événement très rare, même dans le climat actuel, mais ça serait encore beaucoup plus rare dans le climat pré-industriel. Et notre système a indiqué que cet événement était au moins 10 fois plus probable à cause des changements climatiques d'origine humaine. Prochaine diapo, s'il vous plaît. Alors, quels sont nos plans pour le développement du système? On développe la capacité d'attribution des températures extrêmes froides et cette capacité sera en place d'ici cet hiver. On développe aussi la capacité d'attribution des précipitations extrêmes, la pluie extrême, et ça sera en place en 2025. Prochaine diapo, s'il vous plaît. Alors, je vous laisse avec cette liste des ressources concernant le météo canadien. Merci.
Merci beaucoup. Thank you, Nathan and Jennifer. We will continue with the question period. Nous poursuivons à la période de questions. To ask your question via Zoom, please use your hand raising function or by phone, press *9 followed by *6 to unmute yourself. To be called upon, we ask that you make sure your name and your media outlet are clearly identified in your Zoom name. Veuillez utiliser la fonction lever la main si vous avez une question sur votre téléphone. Veuillez appuyer étoile 9 suivi par étoile 6 pour établir le son. Pour poser une question, nous vous demandons de vous assurer que votre nom et votre média soient clairement identifiés dans votre nom Zoom. The first question is from Jordan Olmsted of the Canadian Press. Go ahead, Jordan.
Thanks so much for taking my question. I was wondering if you could quickly clarify when and what the records were previously in Quebec and Atlantic Canada, as well as the previous top 3 or the top 3 hottest summers in Canada.
I can pull up some statistics. It'll just take me a second to pull up some information for you. It's a little tough to do on the fly here. Hang on.
I could also ask Nathan a question in the meantime.
Sure, that sounds good.
Nathan, you mentioned the Inuvik heat wave and you showed the graphs around the analysis for that heat wave. For that one, as well as the other northern heat waves, it shows that it basically flattened out in the pre-industrial climate when you put the temperature of those heat waves on that graph. Can you basically explain whether that type of heat wave would have been virtually impossible in a pre-industrial climate?
Thanks for the question. Based on our analysis, it would have been exceptionally unlikely in the pre-industrial climate. As I said in the presentation, we found that it was at least 10 times more likely due to human-induced climate change. And I didn't mention this, but it was a rare event in the current climate. So we estimate in the current climate, its return period was something like 100 years for the Inuvik region. And so, we found that it was at least 10 times less likely in the pre-industrial climate. So yes, exceptionally rare, I would say.
So if I could maybe just a quick follow-up on that one, how concerning is it to see those exceptional heat waves in the north, given how climate change is leading to even more rapid warming in the Arctic?
Yes, I would say absolutely it's concerning. As you said, Canada as a whole is warming faster than the global rate, about twice the global rate, and the north of Canada is warming even more strongly, something like 3 times the global rate. So, yeah, this is an example of that impact of climate change, of global warming on the north. Yeah, it's certainly very concerning. The ecosystems, communities are not adapted to those kind of temperatures. So it's certainly very concerning.
Thanks.
Please
Maybe
go
just
ahead.
the previous records.
Yes, so for Quebec specifically, the previous records for 2024 in terms of daytime maximum, I guess in the I don't think I have the exact date of the previous records. I just know by how much they beat their previous record based on the quick data that I have on hand. Would that be of interest to you?
Sorry, is this is the previous summer temperature record? Because
Were you
Nathan
looking?
had, sorry, go ahead.
No, I just maybe I'm misunderstanding your question. Please explain.
In Nathan's presentation, he said that this summer was the warmest recorded in Quebec and Atlantic Canada on record. And then also mentioned that this was the 4th warmest on record.
I will
in
defer to
Canada.
Nathan for that one then. He will have those broader stats than me. I'm just looking at points. So thank
Okay,
you for
sorry about that.
clarifying.
Thanks.
No, that's all right. All good.
Thank you. Yes, well, I can tell you that nationally, the last year, 2023, was the warmest summer on record, with 2024, as I said, being the 4th warmest summer on record. I'm afraid I don't have I don't immediately have the stats that you were requesting for the Atlantic and for Quebec, but we can supply those after the press conference.
Okay, we will continue to the next question from David Thurton, CBC. Go ahead, David.
Hi, folks. Thanks for doing this. I was just wondering if you could tell us a bit more, looking ahead to your attribution analysis for extreme cold weather. What's going to hit the mark for that? How are you going to determine when it's cold event or extreme cold event hits the mark for doing this analysis? I guess it'd be a certain temperature or a certain amount of snow. Can you talk a little bit about that?
Yes, thanks for the question. So we intend to proceed kind of similarly to what we were doing, how we've carried out the analysis for the hot event. We'll be looking at the minimum temperatures averaged over those 17, the daily minimum temperatures averaged over those 17 regions. For the hot extremes, our trigger criterion is based on when the temperature exceeds a certain threshold, the 90th percentile of the distribution, and we are planning to do something similar for the cold extremes. But it will be based on the minimum temperatures averaged over those regions, and we'll be looking at events that are colder than some threshold to determine when we carry out our analysis. I should mention that climate change generally is causing, well, it is causing warming. It's increasing the likelihood of hot extremes, but it is decreasing the likelihood of cold extremes. So we expect to find that the events that we analyze are becoming less likely because of human-induced climate change, the cold extremes that we analyze.
Okay, so that's what the analysis is going to be looking at, is how less likely this cold extreme would be, not necessarily how likely.
Correct. We'll be looking at how climate change affected the chances or the probability of each event. Yes, and we expect to find that they will be less likely because of climate change.
Okay, thank you so
much. Okay. To ask a question via Zoom, please use the hand raising function. Veuillez utiliser la fonction main levée. Oh, I see Jordan has another question. Go ahead, Jordan.
I'm not trying to jump the queue though, if other people have
No, go for it.
Okay. I was wondering, Nathan, the kind of implications of studying heat waves is a little bit more obvious given the kind of dangers and health risks. Can you explain why studying those cold events as well is kind of a priority for ECCC?
Thank you. I mean, I guess studying cold extremes kind of follows on naturally from studying hot extremes. We can apply a similar kind of analysis. But I mean, cold extremes, they are important, and they are important in terms of their impacts. And obviously, cold extremes can have negative impacts on communities. Although there are some aspects of cold extremes where having fewer is a bad thing. For example, if we think of mountain pine beetle or other pests which can be killed by cold extremes, and if we're getting fewer cold extremes, that can lead to, for example, mountain pine beetle spreading into new areas. So certainly they can have impacts, and also it's from a scientific perspective, it's natural to extend our analysis in this way from the hot extremes.
That's great. And I'm wondering, now that you have like this summer's worth of data on this rapid attribution tool, did the results, and I know this is maybe like a bit more kind of conversational, not quite a scientific analysis, but like how did the results stand out to you? And what did you notice kind of in the results that maybe you weren't expecting when you first set out to apply this tool?
Yeah, thanks for the question. I think it is interesting to carry out the analysis for so many events. I think we kind of set up the scale, and we didn't really. I mean, we had run the analysis on past years, but we didn't know how many events we would find in each category. I think it is striking that we're finding some events in the past summer that were in our highest category more than 10 times more likely. And all the events were significantly more likely. I would say that I think we learned more about the system. Typically when you carry out an event attribution analysis, you just look at one event and you run the analysis and you report the results. But I think we did learn more about how we do the analysis by looking at a large number of events over the summer. So yeah, I would say that the results it was striking that we got some heat waves occurred that were in that highest 10 times more likely category. And like I say, I think we learned more about the analysis by carrying it out for this many events.
Okay, we'll continue to Anand Ram with CBC News. Go ahead.
Hi there. Thanks for taking my question. This one's a bit of a weird one. I apologize. But this week, World Weather Attribution talked about the floods in Africa and the extreme rainfall over the summer there. And so it got us thinking about, the sort of health impacts of what that results in. Heat, of course, has that as well. So my question is really, do these studies, and in studying heat this summer, does it inform your colleagues perhaps at Health Canada and otherwise about the sort of increased risks that climate change brings to that, or does it just sort of kind of just they already have all that?
Good question. I think it does inform colleagues in Health Canada research on health impacts of heat waves. We know that heat waves are in fact the most deadly weather extreme affecting people. And if we think of the 2021 heat wave in BC, which was associated sadly with more than 600 deaths in British Columbia, that is a measure of how important heat waves are for human health. So yeah, I think this kind of quantitative information on heat waves that have actually occurred is useful for that kind of research. Certainly we know that heat waves are projected to become more frequent in the future. But I think that if we can link climate change with specific events that people can study and have data for, I think that does help research on climate change impacts on human health.
Great, thank you. And this might be more of the same, but it's actually a different dynamic. But similarly, when it came to Hurricane Milton and Helene, there was an analysis done on the direct economic damage that climate change could be, I suppose, faulted for or contributed to. Do you perceive any sort of like window in which, because we've already hit $7.7 billion of insured losses in Canada for various disasters already? Do you perceive any sort of future where these kinds of rapid attributions might be extend into the economic realm?
Good question. I mean, I don't think we're not going to do that directly, but we are. I think they could be, and the results from our studies can inform partners and collaborators that are working on impacts of climate change and including economic impacts of climate change. And certainly, just to build on what you said, we know that, for example, the Fort McMurray wildfires, which were the costliest insured disaster in Canada. We've done event attribution studies on the fire weather associated with those that finds an impact of climate change. We've done event attribution studies on the BC floods, which were the costliest insured disaster in BC. So yes, I think that there is. I wouldn't say we're within our team going to do that kind of economic event attribution, but I think the analysis can be useful for that, and that is we are talking with a range of partners on applying our results.
Okay. Our next question is from Stéphane Labbé from Glacier Media. Go ahead.
Hi there. Thanks for doing this. For Nathan, could you talked about how other rapid attribution studies take months, sometimes years to complete. How is it that you can do this so quickly?
Thanks. Yes. So, I mean, typically, if you just wait till an event happens and then you decide that you're going to do an event attribution study, you have to download, you have to assemble data, observe data on the event, you have to assemble model simulations, you have to decide how you're going to do your analysis, what region you're going to look at, and then once you've got all that, you have to write up some code to do the analysis. But we can do most of those steps in advance. So if we decide what regions we're going to do the analysis for, we decide what that we assemble the output from climate models from around the world. Then really we just need to get the latest observations for the last few days, and then we can, and of course we've written the analysis code already. We've evaluated the models. So then really it's just a case of running that code. So getting the latest observations and running that code. And then that's something that we can do within about a week of an event occurring. So yeah, that's really how we can do it more rapidly.
I mean, I'm just trying to understand, like, is the way you do it much different from the way that these international collaborations, people from like World Weather Attribution do it, or is this just the same thing, but like a plug and play kind of model or something?
I would say I mean, there's quite a lot of similarities with the way that World Weather Attribution does their analyses. I mean, they have kind of a set framework for how they're going to carry out their analysis. They have the data already assembled. So I mean, in our case, we are actually doing this automatically. So we've got these regions defined. We download the data automatically, and then if a heat wave is kind of detected, then we carry out the analysis automatically. World weather attribution is, they're looking at the whole globe and they're looking at a range of different extremes, so they make a sort of expert decision of which events they're going to analyze. So it's, I would say it's a bit less automated, but there's certainly a lot of similarities in the two approaches in terms of having the framework defined ahead of time, having the model data there ahead of time.
Okay, last call for questions. If you have a question, please use the hand raising function. Veuillez utiliser la fonction main levée si vous avez une question. Dernière option pour demander une question. Okay, this concludes today's media. Ooh, I see some hands. Sorry. Was it Ian? Or I saw somebody has a question and I see Stefan has an additional question. Stefan, go ahead. And if somebody else has a question, feel free to raise your hand.
Thank you. Yeah, just Nathan, sorry, one more time. I'm just curious if you could comment on why you're doing this. Besides curiosity and understanding, what do you hope to achieve with this rapid attribution tool?
Yeah, thanks for the question. So I think providing rapid event attribution analyses, as I said in the presentation, it can be useful for informing climate change adaptation, informing the response after a big weather event happens. If we think of, and you may have heard me talk about this before, but if we think of the BC floods in 2021, where there was a lot of infrastructure damage, a lot of bridges destroyed, if you're making decisions about rebuilding those bridges, you need to know whether this kind of event is going to happen more often in the future than it has in the past, and whether it's happening more now than it has in the past. That can help inform those decisions on rebuilding that infrastructure. Also, in terms of climate change adaptation more generally, I think people can relate to real events that they've seen much more easily. And if we can provide rapid information on how the odds of an event were changed by climate change, that's kind of a lot less abstract than just telling people that heat waves will increase by some percentage or some factor in the future. So I think it can help inform adaptation. It can help inform the response after extreme events, and also I think it can help people's understanding of climate change. Again, I think on an individual basis, it's easier to relate to information that a particular heat wave or a heavy rainfall was made twice as likely, for example, by climate change than just some projection that 50 years in the future this kind of extremes is going to become more likely. So yeah, I think that those are a couple of the reasons why we're doing this.
Okay. Please use the hand raising function if you have a question. Veuillez utiliser la fonction levez les mains si vous avez une question. Okay, go ahead, Ian Gregg. Go ahead. Ian Gregg for CFU Radio 88.7 FM. Go ahead.
Thank you. If you can hear me now. Do you have a method of measuring the retention of precipitation over the colder winter months? I'm curious because in Prince George region, wildfire activity has been of great concern. We've received a reasonable amount of precipitation this year, but a lot of it is not necessarily in the form of snow, which is retained over the winter and then released in the spring. It's a little bit dodgy around here, and I'm wondering if that is represented within your data.
Thanks. Maybe I'll go first and then I'll refer it to Jen, if that sounds good. I mean, it's certainly the case that the amount of winter snowpack is important for wildfire. And so, yeah, I think you're right that it does make a difference for wildfire how much precipitation we get as rain as rain versus snow. I don't. I think Jen can probably comment better on the the current conditions in Prince George this year. But yeah, I would say, of course, we do have data for how much precipitation fell as rain versus how much fell as snow. That's something that in our broader group we're looking at projections of rain versus changes in snow, and certainly there are impacts, as you've just said, there are impacts on how much precipitation we get of rain versus how much we get of snow. It's not something we're planning to implement in our attribution system kind of immediately, but it is something that we think about more generally in terms of providing data for on climate change to inform adaptation. So yeah, I'll pass to Jennifer.
Okay.
Thank you for the great question. It's tough to speak to exactly one spot, but I can certainly just looking quickly through some data here on our sort of relative precipitation anomalies over time. And yes, obviously BC's had a lot of rain this fall to sort of hopefully account for some of the deficit that we've had for some time. But most of Canada still has a long way to go to reaching its I guess what is considered a normal amount of precipitation, where we're still in a bit of a backlog, especially like a little bit further north of Prince George in northeastern BC and across the southern portions of the Northwest Territories and into Alberta. It's still quite dry this summer, so it'll be hard to know. We'll have to see how this winter unfolds as to how that will inform next summer. But it's tough because sometimes you get precipitation at the time when you don't need it and you don't have it when you do need it. So it's hard that you get precipitation, and so the amounts that show for the year show a certain amount. But if you don't have the precipitation in the summer season when you need it to mitigate sort of the hot, dry, windy type conditions that would be supporting wildfires, it makes it a little bit challenging. So hopefully that answers your question.
Certainly. Thank you. Yeah, it was kind of in regards to how glaciers are kind of shrinking across the region and not really being recharged by snowfall during the winter.
Yeah,
yeah.
Well. The pattern plays a big role, and we'll see how this year's pattern sets up as to whether or not it's we'll see an increase in snow amount. I don't know that would be a contributing factor for glacier redevelopment, but certainly we'll have to see what the winter holds for this year's snowfall. And that's really all I can say. I don't know the forecast. I can't really give much of a forecast beyond sort of a few days at a time in terms of specifics, but we're hoping that places that need snow and rain get it. But apart from that, I can't give you a more firm answer.
Okay, so this concludes today's media availability. Thank you. Ceci conclut la conférence de presse. Merci beaucoup.